Good morning, agent. Your mission for today is to solve the question given.
Don't forget that your assignment should include the following: solution for each question and creativity. Final date of the submission of your project is 18 December 2019 before 5 p.m. Good luck, agents. The world is counting on you.
Hi! Hi, Ju! What are you doing? We have a question. Our mission, no? Yes, our mission. I already read the mission. Yes. But I don't understand. Which part? This part. Oh yeah, this part. Oh, like this. Firstly, you need to understand this. This question ask you.
Based on the question given, we need to find the value of t of the given equation by using bisection method. We need to consider the initial interval 0, 5 and error tolerance accurate to within 0.0001. It is given that Rn equal to 4D when R equal to 10 inch. We need to work our solution in 4 decimal places. Firstly, we need to simplify the nonlinear equation and change it to a function by substitute Rn equal to 4D and R equal to 10 inch. Then we calculate until we get the function. Next, we need to construct the table using bisection method and evaluate it until the error tolerance accurate within to 0.0001. Hence, we will get the value for D is 2.4904 at 16 iteration.
For the question 2a, it is stated that a balloon moves in the xy plane according to the law x equal to at and y equal to bt squared, where a is greater than 0 and b is also greater than 0. The question 1 Roman asks us to determine the balloon's trajectory with function of y and sketch its graph. Firstly, to determine the balloon's trajectory with function of y, we need to evaluate the equation y equal to bt squared. From the given equation x is equal to at, we can determine the equation of t equal to x over a. Then we substitute t equal to x over a into the equation y equal to bt squared. Then we will get yx equal to bx squared over a squared. And to plot the graph is when we know that a is greater than 0 and b is greater than 0. We can assume that a is 1 and b is 1. Then we substitute the value of a and b into the equation yx equal to bx squared over a squared. Then we will get yx equal to x squared. Then we need to construct a table for the x and y axis. Then this is the table. Next, plot the graph by using the table. For the question 2 Roman, we need to determine the speed of the balloon as a function of time t. As we know, the speed is the magnitude of the velocity of the particle move. Hence, RT equal to ATI plus BT squared J. From this equation, we need to find the velocity. By differentiate the equation, then we will get AI plus 2BTJ. Then calculate the speed by magnitude the velocity and we will get Z1 plus 4t squared. For the question 3 Roman, we need to find the angle between the velocity vector and the x-axis. To find the angle, we use this formula where Vt.xt equal to magnitude of Vt times magnitude of xt times cos theta. Then evaluate the formula and we will get theta equal to arc cos 2 over Z1 plus 4t squared.
So for this question, we need to find the velocity, acceleration and speed of a particle by the position function rt equal to cos ti plus 3 sin tj at t equal to 0. And then we need to sketch the path of the particle and draw the velocity and acceleration vectors for the specified values of t. Step 1. Firstly, we need to calculate the velocity, speed and acceleration formulas for an arbitrary value of t. In the process, we substitute and find each of these vectors at t equal to 0. To find the velocity, we need to differentiate the position function rt and we will get rt equal to negative 2 sin ti plus 3 cos tj. And when we substitute t equal to 0, we will get vector's velocity at coordinate 0, 3. Then we need to determine the speed, which is the magnitude of the velocity, and we will get the speed at 3. Next, to find the acceleration, we need to differentiate the velocity vector, and we will get the acceleration at -2 cos t minus 3 sin tj. After we substitute t equal to 0, we will get the vector at coordinate -2, 0. To graph the path of the particle, we need to take the position of function rt equal to 2 cos ti plus 3 sin tj. And then we need to write the parametric equation x equal to 2 cos t and y equal to 3 sin t, and solve for the trigonometric terms to get cos t over cos t equal to x over 2 and sin t equal to y over 3. After that, we need to evaluate the Pythagorean identity until we obtain the value of x over 2 square plus y over 3 square equal to 1. From the graph, we can see that the equation of an ellipse with center 0, 0. The vertices on the x-axis are 2, 0 and -2, 0, formed by taking a equal to square root 4, which is 2, and moving to the left and right of the center on the x-axis. The vertices on the y-axis are 0, 3 and 0, -3, formed by taking b equal to square root 9, which is 3, and moving up and down from the center on the y-axis. To find the position of the particle at time t equal to 0, we need to take the position function of r, which is 2 cos ti plus 3 sin tj, and substitute with t equal to 0 to obtain the position function of 2, 0. The terminal point of this vector 2, 0 give the initial point to plot the velocity and acceleration vectors at t equal to 0. We found that when t equal to 0, v is 0, 3 and a is -2, 0. The following shows the result of the graph with the equation of the ellipse x squared over 4 plus y squared over 9 equal to 1. Plotted in green, the velocity vector v, 0, 3 in orange, and the acceleration vector a, -2, 0
in grey.
And from this graph, we can see that the red line is the velocity vector and the grey line is the acceleration vector.